All right, let's dive into JavaScript. It's this language that can pretty much build anything you can dream up. But here's the thing. It is a language of incredible power and just deep, deep contradictions. It's a real love-hate relationship for a lot of people. I mean, just look at this. How can a language be both wonderful and absolutely horrible for beginners at the exact same time? Well, on one hand, it's amazing, right? It's the language of the web. You can get started right in your browser, no setup required. But on the other hand, oh man, it's weird, it can be kind of ugly, and it can feel totally and completely overwhelming. And this quote, wow, it just perfectly captures that feeling. As a learner, you're not just learning a language, you're trying to find your way through this massive, constantly changing ecosystem of tools and frameworks. It really can feel like a wasteland out there. So where did this whole thing come from? Well, it all started back in 1993. A guy named Brendan Eich at Netscape basically invented it to make static websites feel, alive and interactive. Fast forward to today, it's standardized as ECMAScript. That's just the fancy official name for the language. And it's the only programming language that runs in every single web browser. But it didn't stop there. It broke out of the browser and now powers huge servers with tools like Node.js. That was a total game changer. Okay, so with that history in mind, let's zoom in a little. We're going to look at the fundamental building blocks of the language itself. This is really where the journey begins. The classic hello world. To get started, all you really need is an HTML file and this little script tag. Inside, you use a built-in command, console.log. This basically just prints whatever you want into the browser's developer console. That little window developers are always staring at. It's the simplest, quickest way to see your code actually do something. Next up, variables. The easiest way to think about them is as labeled boxes where you can store information for later. In JavaScript, you'll see three main keywords used to create or declare these boxes: let, const, and the older one, var. So what's the difference? Why three? Well, it really comes down to two things: scope and reassignment. Scope is just where in your code the variable is alive. Let and const are block scoped, which means they only exist inside the curly braces they're created in. They're predictable. The old keyword, var, is function scoped, so it can kind of wander all over the place, which, let me tell you, can lead to some really weird bugs. That's why today you almost always want to stick with let for things that might change and const for things that won't. So what kind of data can we put in these variables? Well, it comes in a few basic or primitive types. You've got your numbers, strings of text, undefined for when a variable is created but hasn't been given a value yet, and null for when you want to say it's intentionally empty. Now, here's the most important part. If it's not one of these simple primitive types, it's an object. That's a huge concept in JavaScript. And to actually do things with all this data, we use functions. These are the workhorses, the real engines of any JavaScript program. They're just reusable chunks of code. You can give them some input, which we call arguments. They do some work, and then they can give you back a new value. Super powerful. All right, we've covered the basics. Now let's move on, because this is where things get a little more powerful, and frankly, a whole lot weirder. These are the ideas that often trip people up. First up, the infamous this keyword. Oh, this. In most languages, it's pretty straightforward. In JavaScript, it's kind of a shapeshifter. It's a keyword that always points to an object, but which object it points to can change completely depending on how a function is called. It's a classic source of confusion and bugs, though thankfully modern arrow functions have made its behavior much, much more predictable. Next is how JavaScript handles inheritance. A lot of languages use these rigid blueprints called classes. JavaScript's way is more flexible. It uses something called prototypical inheritance. Think of it like this. Every object can have a backup object. If you ask for a property and it's not on the main object, JavaScript automatically goes and checks its backup, its prototype. And that class keyword you sometimes see, it's really just a cleaner, nicer syntax, what we call syntactic sugar, on top of this older prototype system. This concept is a huge one. By default, JavaScript code runs one line at a time, synchronously. The second line has to wait for the first to finish. But imagine your whole website freezing up while it waits for some data to download. That's no good. And that's where asynchronous code comes in. It lets you run long tasks in the background without blocking everything else. And handling this async stuff has gotten way better over time. In the early days, we used callbacks, which often led to this deeply nested, confusing mess of code that people literally called callback hell. To fix that, we got promises, which are objects that represent a future value. And now the modern solution is async/await, which is some beautiful syntax that lets us write asynchronous code that looks and reads like simple synchronous code. Each step was a huge leap in readability.
Okay, so we've been deep in the weeds of the language. Let's zoom back out and take a look at the wider universe where JavaScript lives and gets its work done. JavaScript really has two main homes. First, the browser. Its main job there is to interact with something called the DOM, which is just a live representation of a web page, to create all the cool interactive user interfaces we use every day. And second, on the server. Using runtimes like Node.js, JavaScript can build the entire backend that powers modern web applications. So let's talk about the DOM for a second. Imagine your HTML page is like a family tree of all its elements. The DOM is basically JavaScript's way of seeing and talking to that tree. With some pretty simple commands, your script can find any element, listen for user events like a click on a button, and then dynamically change the page right in front of the user. This is the magic behind every interactive website you've ever used. And this brings us right back to that dystopian wasteland we talked about. See, a modern developer almost never just writes plain JavaScript. They use a whole ecosystem of tools to make their lives easier. NPM to manage and share code, frameworks like React to build complicated interfaces, bundlers to package it all up for the browser, and linters to keep the code clean and consistent. It's a lot. And after navigating all of that, the language itself, the browser, the server, the frameworks, the build tools, you can definitely start to feel like you've got 99 problems and JavaScript is somehow connected to every single one of them. It is a lot to juggle. So after all of this, the weird parts, the complexity, the chaos, you really have to wonder. That same chaos is what has allowed JavaScript to spread literally everywhere, from websites to servers, even to mobile apps. It adapts, it evolves, it just survives. Which leaves us with one last thought. Maybe, just maybe, JavaScript's chaotic nature isn't its biggest flaw. Maybe it's its greatest strength.